Action potential is the change in electrical potential associated with the passage of an impulse along the selectively permeable membrane of an excitable cell. Action potential occurs when the body stimulates a response to touch or injury. Action potential works to send a signal along the membrane of a muscle or nerve cell to alert the brain of a sensation. At resting potential, when the cells have not been stimulated, the cell membrane is at an electrical charge of negative 70 millivolts, and there is a high concentration of positively charged sodium ions in the extracellular fluid, or the fluid outside of the cell membrane. There is also a high concentration of positively charged potassium ions in the intracellular fluid, or the fluid within the cell. When a person is touched or injured, an action potential begins. When an action potential occurs, the resting potential of negative 70 millivolts begins to become more positive. Once the voltage reaches negative 55 millivolts, the cell has reached its threshold, which begins the depolarization of the cell membrane. The inactivation gates close and the activation gates open. This begins the absolute refractory period in which no other action potential may occur. During the depolarization phase, the voltage-gated sodium ion channels open, allowing sodium ions to rush into the cell, causing a rapid influx of sodium ions inside the cell membrane and an efflux of potassium ions, which changes the charge of the inner membrane from negatively charged to positively charged. Throughout depolarization, the electrical charge of the cell membrane continues to go up. Once it reaches positive 30 millivolts, the voltage-gated sodium ion gates close, and the voltage-gated potassium ion gates open to begin the repolarization phase. During the repolarization phase, potassium is pumped back into the cell through the voltage-gated potassium ion channels that are located on the cell membrane. Following the repolarization phase, there is a state of hyperpolarization, or an overshoot phase, that the cell membrane goes through when the charge of the cell drops past resting potential and to negative 90 millivolts, due to the potassium channels remaining open for too long. During this stage, the cell enters the refractory period, where a very large stimulus could cause another action potential to occur. The cell is finally brought back to resting potential using the sodium-potassium pump. The sodium-potassium pump pumps out 3 sodium ions and pumps 2 potassium ions back in. This is how an action potential occurs. Thank you for watching.